First of all, good morning. My name is Demi. We'll be talking today about hacker versus company and automation via Kubernetes of all of the security measurements and things that companies need to do. And mostly we'll focus about the use case of how taking a technology and a problem that we've had and integrate it with the, let's say, a workflow of actually people doing that and the integration of DevSec and Ops today. So it works, yes. So because it's a talk about cybersecurity, we have to have a hoodie and somebody actually trying to hack something. Okay, so this is a lot our head of security research doing his thing. And once we have that off the table, I'll introduce myself shortly. My name is Demi Ben-Ari. I'm the VP R&D and the co-founder of Panorays. In the past, I was in the Israeli Air Force at a unit called OFEC. And there I developed a missile defense system. I was a team leader, a software engineer, and then a senior engineer. And afterwards, when I left the military, I started working in a company called Windward. Basically, what I did with missiles in the Israeli Air Force, I did with ships when I left the military. By the way, can you hear me well? Okay, even if I move here? Okay. Awesome. I am also one of the co-founders of several developer communities, one called Big Things, focused in big data, data science, and DevOps, and also GDG Cloud. Guess what it's based on? Cloud. Also, I'm a Google developer expert. That basically means that Google certifies me that I talk a lot and really fast. So if you don't interfere and ask questions during the session, I will just continue on talking. Okay, so it's really important to try to make it as much interactive as possible. Okay, so because people told me in the beginning before the talk, are you going to do your thing? So probably I wasn't planning to do that, but we'll do a pre-talk selfie, okay? So everybody just raise your hands and say security or cyber. Awesome, awesome. Great that you're compliant. Okay, so we'll start. Some important things about this talk, okay? I'm not a Docker, Kubernetes, or specifically a security expert. What you won't be after this talk, the same things. Docker, Kubernetes, or security experts. Basically, what you will be after this talk is much happier people because I've stopped talking. And you'll know at least where to search about the things and the terms that I'm going to talk about in this talk. You will also know the meaning of life. Okay, what is cybersecurity? This is when you're talking about a lot of failures in the world of cybersecurity. Basically, it's a lot of bugs, we would say, okay? Security bugs. And mostly things that are unplanned or not planned correctly. But basically, if we try to define cybersecurity, it's mostly focused on technology, because people are trying to hack technologies, about action that we take upon when we find these security gaps, and also about process. How many of you are working in enterprises or large companies that have processes? Okay, these processes are basically part of the solution to the problem of cyber gaps and cybersecurity, because a lot of times, not only technology can prevent a lot of things that are really bad in the matter of what we're doing with software. A lot of times, because it's annoying to do something, and because of processes, we can prevent a lot of, like a really large percentage of security flaws. But when we come to solving the problem of cybersecurity in general, we need to take into account two things, okay? We don't have an unlimited amount of resources to invest to create the best security possible. So we're trying to do as much effort as possible in the matter of resources, the lowest amount of resources, to get the best possibility of security in our organization. So because of that, we need to say cyber, because we see cyber risk everywhere. But where do they come from? Okay, this is one of the most important things that we need to take into account, because we need to think about what we're trying to actually protect our, like, what assets are we trying to protect? So if we look at that, we see files, identities, okay? We want to talk about anonymity or pseudo-anonymity. But these are our organizational assets that we're trying to protect. This might be technology, this might be information. But what measurements do we have to actually protect against other like adversaries. Okay, so we're talking about WAFs, VPNs. How many of you know Tor? Hidden services, okay? All of these like methods that we can put in place to actually protect ourselves. But what are we trying to protect ourselves against? Okay, this is the most important thing to actually notion. And phishing, vishing, spywares, malwares, and lots of like security gaps that we introduce when we introduce new software to our tool set. But who are we trying to protect against, right? I would say like 20 years ago, it would be spies, it would be like large attack organizations, maybe even hackers, crackers. But today it can be even a 15-year-old who downloads Kali Linux, runs some brute force with AWS or any like cloud service provider, and basically hacks a really large enterprise's organizational system. So I will tell you a bit about my company, Panorays, and what we do. I won't elaborate much, but we help large enterprises and basically any company to manage the cybersecurity risk that is imposed by their suppliers. If like 20 years ago, a CISO, a Chief Information Security Officer, would say, I'm really safe, okay? I'm a safe silo. I'm paying tens of millions of dollars about like cybersecurity products. Let's pretend that this lie is true. Today, you're using external services for everything, okay? It can start from your cloud service provider, emailing services, marketing tools that you introduce to your own infrastructure, but it can be even your law firm, accounting company, or even one of our customers told us about his flower delivery company, and we were like, what? Why does that matter at all? And they say that they have a list of all of their high-ranking employees, all of their most valuable customers with their names, addresses, phone numbers, and birth dates in which you actually assemble passwords out of. So any vendor can impose a risk on our organization. So what we do is we look at a company in the hacker's point of view. We kind of orchestrated the whole reconnaissance phase of a hacker, and basically mapping out the attack surface of any organization, IT and network, application layer, all that is out-facing to the customers, and also the employees, the stupid factor, okay? The most vulnerable vector possible in companies, and we monitor all of that and create some kind of rating mechanism on top of it. But let's talk about technology. What was our problem when we actually introduced, because we said that we'll talk about Kubernetes and cloud and all of the automation of security. I would ask, what is the hardest problem in software engineering in general? Cache invalidation. Awesome. What? Okay, software engineering is broad. I know we're a problem. You are correct, okay? I always say that we as developers write bugs, okay? We don't write code. Because of that, I'm really like satisfied with every line of code that I actually erase. But again, can you come up with other things? What? Human education? Okay, actually, yeah. Training is painful. But if you'd ask any developer, and what are you wasting most of your time during the day? It's basically naming things, okay? How many of you have problems and arguments with other developers about how to name components, variables, even like most of the code reviews upon things are like, this is not clear enough. And because, you know, it's a tech conference and tech talk, I need to show something scientific, so I went to Quora and showed some kind of research that basically 49% of developers say that naming things takes the most time of their day, okay? So we need some kind of solution for naming things, right? So the simple solution is basically appointing a CNO, okay? Chief Naming Officer. This is the guy with the go-to guy to the hardest problems possible. This is Tal. He was our data scientist. And basically, we would go to him every dispute that we've had on naming things. But let's talk seriously. We need to define the problem, actually, of what we're trying to handle to kind of solve it, of course, right? So what we had, because we're orchestrating the whole life cycle of a hacker, basically doing the reconnaissance phase, we have a distributed system. So we had a problem in the beginning, of course, like every startup company, we started off with VMs, right? It's really easy to deploy code, and most of our code was actually in Python, because I think more than 80% of tooling today in the world of cybersecurity is in Python, so it was a really easy go-to. And we used to launch a VM per company that we want to scan. So basically, I'm scalable because I'm using Google Cloud and it's awesome. But still, I am paying a lot of money to launch a lot of VMs, and this doesn't scale when you go to the larger numbers of thousands and 10,000s of actual companies that you're scanning. How many of you have tried to actually build some kind of orchestration framework for yourselves? How fun was that? How fun was that? Only in the beginning, right? And when things start to blow, and it's harder if it's in the manner of hundreds of thousands of things running. Yeah, I know it's painful. So like every small company that doesn't have resources, we started off with something common. Okay, we started off with cron and bash of actually doing things and orchestrating everything ourselves. And of course, server utilization was really, really low. Why? Because I'm doing a lot of scans, right? What do I mean by scans? Scans means I/O, going outbound, network, right? And okay, so maybe I'm utilizing the network card, but the CPU is practically idle most of the time. So I'm wasting money in low utilization of servers. And also, how do you monitor all of that? Okay, if you have even 100 moving parts and you don't have a proper monitoring system, it's really, really hard to keep track on things. And of course, I want to control everything because we're geeks with APIs. I don't want a GUI for that, right? Hard. But it's not the only problem. You need to understand the people involved. How many of you are software developers? Okay, and how many of you are DevOps people and ops people, infrastructure-wise? Awesome. So it's pretty much half and half. We had a new kind of beast, okay? Security researchers. How many of you are security people? Okay, awesome. A low amount of people. It's good that you affiliate to that. These are really talented people, but when you take it in the matter of like system engineering and doing things in scale, this is not a skill set that they come with a lot of times. Okay, not everybody, but most of the people actually come with, they can break walls, okay, but when they need to break multiple walls, it gets much harder. And how do you actually make them, or at least give them the ability to write production code and deploy code as they were like regular software engineers? This was one of the biggest problems that we've hit in the beginning because we needed expertise from the world of cybersecurity, and again, you don't have a lot of resources. So it's a problem. So, of course, creating a CI/CD pipeline, okay, it might be a good idea. And, of course, how do you make them deploy code to production without being afraid that your whole production system will blow up? Okay, so again, like every startup company, we started off with thinking how to implement that, right? A monolith, and like try to deploy quickly when you have a small team of at least like 5 people that are doing code. Or be like all of the cool kids on the block and build microservices, right? Everybody likes that buzzword. Even in the keynote, we've talked about it. And what you eventually end up is with what I call a microlith, okay? When you start dismantling the monolith, you end up with some kind of microservices architecture that basically deploys only with a single bunch, okay? And it's a big problem. Bless you. Okay. So what we've had in the beginning, bin and bash, okay? We had a virtual server. We had many virtual servers. And of course, everything used to run sequentially per company. So we had all of the jobs running sequentially on a company. So if it's a really large company with a large attack surface, it used to take a lot of time. So it was a problem. We needed some kind of orchestration framework to handle that, like heavy lifting for us. So we've created the transporter, okay? The transporter is a workflow manager that is based on top of Kubernetes and Celery in Python, if you know it. And you know, we've talked about Airflow and a lot of technologies in the keynote. How many of you know Airflow, Spotify's, Luigi? Okay, some kind of like orchestration framework. So we're being asked a lot of times, why didn't we use any like out of the box tool that is out there and it's open source and everything? So basically this whole like incident, I would say, happened more than 2 years ago, and all of these things didn't fit us much, let's say, because we have a really wide variety of types of jobs. A job can run in a matter of microseconds, and it can run for multiple, like even minutes, and it can be even half an hour plus if it's a really vast and massive job. Okay, so the transporter should be like flexible, efficient, parallel, and fully automated. Okay, so these were the things that we've tried to kind of tackle because we didn't have that in manner of like launching virtual machines. And what we've created basically an interface with Flask in Python that communicates with Celery as a distributed task queue and on top of RabbitMQ. And of course, all of the execution occurs on Kubernetes. I would ask, how many of you know Kubernetes? Okay, keep your hands up. How many are using Kubernetes in production? How is it possible that you raise your hands right now? Okay, awesome. So I'll describe Kubernetes a bit because I know that there are people that might have not heard of it. Kubernetes is an open source tool that is based on Google's Borg. It's an internal orchestration framework that they've had. They have, I think, more than 50 or 20 years of experience with that, of launching containers, and they've released that to open source to kind of put that out there, all of their best practices. It's fully open source, written in Go, and it's the most common orchestration framework for containers in general in the world today, and the fastest moving open source project. If you want, you can contribute to that, you can use that, but how do we know that it's one of the leading orchestration frameworks? Because all of the leading cloud service providers, Google, that has, I think they were the first to have a managed service of Kubernetes, and Amazon and Azure have like adopted it as their de facto managed service of Kubernetes, okay? How many people are here vegan or vegetarian? Okay, I apologize in advance. No, not because of like you guys, because of what I'm going to say. I'm going to like give you an analogy of how we used to treat servers and how we treat servers when we're using Kubernetes. So in the past, we had like really beefy servers. They were like pets, right? Everybody had a name. They were unique and rare and different. We gave them personal attention. We used to pet them a lot. Okay, if it gets ill, we make it better. We update, we patch, yada, yada. But today with Kubernetes, we have the ability to actually be a bit more brutal, I would say, okay? They are like cattle. Everybody has a number. One is much like the other. And basically, they run as a group. And if something gets bad, we basically kill them and make hamburgers out of it. So because of that, I apologize. Awesome. A lot of times when people talk about Kubernetes, they use to talk about all of the these kind of like terms. Deployment services, they like to show blue-green deployments and all of these kind of like long-living services, which are really, really cool, and all of the examples go there. But a lot of our work, at least at Panorays, and I know with a lot of companies, especially in the world of DevOps, are batch operations, okay? And because of that, we kind of try to leverage one thing that people usually don't take as an example of jobs. How many of you like know distributed frameworks like Apache Spark, batch operations, massive batch operations on top of infrastructure? So we'll have a lot of these use cases, but a lot of times people don't talk about it. Okay, so why the transporter, okay? How many of you saw the movie, Transporter? Oh, not too many, okay. It's a really cool movie that basically means nothing, okay? A lot of explosions and things. But we took some guidelines out of that movie, okay? And we'll discuss it with the features that we've actually implemented in Kubernetes. So basically, the deal is a deal. No names. Never open the package, and never make a promise that you can't keep. Okay, these are like the guidelines that we went through when we created the transporter. What that means, basically, we took the whole like workflow and the life cycle that we wanted to create, and we dismantled it to smaller pieces, jobs, phases, and workflows. And what that means, never make a promise that you can't keep. We need some kind of reprise mechanism. We need scheduling, okay, timeouts, because this is really important in a distributed system in which you want to know that things keep on running. And never make a promise that you can't make, that you can't keep. It's basically failures and notifications that we want to see on all of our infrastructure, and not just things blowing up in the background and us not knowing about it. No names, again, we spoke about security researchers. So we kind of hit a specific limit of Kubernetes because they were over descriptive about their own jobs when they named them, of course. So we hit the limit of 63 characters of the name of a Docker container, and things started blowing up, and we didn't know why. So we kind of created our own mapping mechanism to hashes, and then we had the descriptions on a different place. It actually was a really stupid bug that occurred during the development cycle. Okay, so what do we have on our cluster? And this is like some consideration that you need to take when you're going to implement some kind of solution with Kubernetes. A lot of times people like to talk about single tenancy and multi-tenancy, right? I want to be as efficient as possible with my own infrastructure. So how do I divide my workloads according to the network that I'm on top of? By the way, how many of you are working on premises and not in the cloud? Okay, so you need to manage your own infrastructure, right? You have your own DevOps people, or you are the DevOps people managing the infrastructure, and the scaling is on you guys. So it's really hard to do that also. And you need to think, maybe it's not worth it separating it to two different clusters. Maybe I'd rather actually manage that on a single cluster and manage the whole infrastructure in a single place also. So all of our transporter services are on Kubernetes also. Our workers that take the workloads from RabbitMQ and the whole Celery infrastructure are on there too. Redis for some kind of persistency during the runs of all of the workflows. And Kubernetes jobs that are triggered on a different cluster. And why? Because we are doing a lot of outbound and inbound network traffic, we hit the network limit of Google's GKE specifically and start getting timeouts from the cluster itself, and then the services start failing. So actually what needs to orchestrate the whole workload actually started failing in the beginning. So what we did is basically we separated these things, and we started launching all of the jobs on a separate Kubernetes cluster, which I'm also scalable there. So in the manner of the services, I have my own scale when I need to scale the services and the nodes. And then if I have a really vast workload on larger companies, I basically can scale there on the infrastructure that runs all of the jobs also. Okay, so what's next? Of course, what I actually describe is like as if we solved the problem. No, we're over-evolving with our solution. So in the beginning, we didn't have a lot of things when we deployed that to production, and we used to run A/B with the old infrastructure as well, okay? So in the last like year and a half, or yeah, I would say year and a half, we enhanced a lot of capabilities of the transporter also, enhancing the workflows and the monitoring of that, and we've created a lot of Grafana dashboards. How many of you are using Grafana in production? It's an awesome tool, okay? I can look at monotonic graphs all day long. And we've added a lot of things in the matter of configuration, deployment, and all of these things in the matter of version management, how we integrate our own CI/CD pipeline to our production environment and keep on deploying things rapidly. And of course, asset level parallelization. We've parallelized all of our things in the manner of like other things that we can parallelize and not only servers. For example, if I have an attack surface of a company and we have a lot of assets, a lot of domains, IP addresses, and the subdomains that we're scanning, I don't have to go sequentially there also. Okay. So, conclusions. I would say, like from my experience, I think 13, I would say, years of doing distributed systems. If you have the possibility of not doing distributed systems, don't do it, okay? I would say, honestly, it's like shit. And, but again, we don't have a lot of time that privilege, and we need to scale our infrastructure. We want to save costs, save money. So basically, we need to go there. Kubernetes is a great orchestration container, okay? Container orchestration tool, and basically you can do that on-prem, on cloud service providers, and the zero to hero actually of using a managed service of Kubernetes is really, really awesome. Installing it on bare metal is not as hard as it used to be in the past. Okay, this is really important to mention because if you didn't have expertise in the world of DevOps, really low-level infrastructure in your own data centers, it used to be really, really hard. Today, I think all of the regular tools like Ansible, Puppet Chef, and all of these kind of things like give you the abilities really easily with playbooks to kind of launch your own infrastructure. Perfect is the enemy of working or giving value. This is a really important thing to note, basically when you're handling developers and when you're handling development lifecycle of engineering. Because we could have, like in the beginning, start off and like get to all of the feature set that we want to use when we're deploying to production. What I think, or presume at least, that would have happened is basically not giving any value to our customers and kind of chasing ourselves continuously, because eventually we won't end up with all of the problems and we won't face them in production. So you'd rather actually start with a smaller feature set of things that you want to deploy, the MVP, for example, of your own infrastructure when you're deploying things, and then over-evolve, because we kind of noticed a lot of things that in the life cycle we thought that would be problematic and they weren't a problem at all, and we would have wasted, I think, more than half a year to kind of implement them if we would hit them. And of course, making non-developers deploy code to production helped us substantially. And what I mean by that is not that I've made my security researchers develop code better. Okay, this is a kind of like side outcome out of it. I know that things might take even like 100%, 150% of time than a regular engineer. But what usually happens in regular cybersecurity companies, not even startups, like really large companies, the security researchers are really awesome with what they're doing, with their day-to-day job. But again, they don't scale their things. So they develop a really cool ability and then kind of like pass it on to engineering for a full life cycle of 2 months to like maybe even 6 or maybe even a year. And when the code actually hits production, it's much, much later, okay? And because we wanted to kind of like shorten the life cycle of actually developing new code and having them also like being connected to the production environment and to the developers, we've created that whole infrastructure. So it's a really like a great outcome, I would say, that basically everybody are involved. And everybody are involved also like with the engagement of customers. And they can see, even if they're not front-end developers and not developing features for the customers, they're in charge of the data. And they're in charge of all of what's blowing up in production. And this is really, really important too. Okay, after I've talked for, I would say like almost more than 25 minutes really, really fast, and your faces are like this. What? Awesome. We have 5 more minutes for questions. Yes? It's, okay, the question was, is it open source? I've been asked that in the past. I'm really sorry, we don't have any time currently to open that as open source, but we can talk about some kind of collaboration if you'd like afterwards. Also, Tal right now is working at a different company, and he would like to also contribute to that. So we can create some kind of guidelines or maybe even like try to think about a roadmap for that. Any more questions? I would ask myself a question that I was asked in the past. Okay, how many of you know serverless? Okay, I am being asked a lot of times, wait, you have a lot of batch operations, okay, you don't want to waste money. Why not try serverless, right? Okay, so again, I'm reminding you, this was 1.5 years ago. Most of you probably, where are you, like, how many people are on Amazon, AWS? Okay, I'm not, but yeah. And how many of you are on Google Cloud? Some. Azure? Some too. Okay. 1.5 years ago, the whole like functions thing wasn't that like mature. Okay? And even in Google, you had only JavaScript. So I needed to run Python. A lot of things that were running are also like native C code being ran by Python. And because of that, I couldn't like add a lot of dependencies. And I didn't have a lot of transparency also on the infrastructure itself. And I would say that serverless things are really tuned for small things, up to a minute. But what happens if you have something of 5 minutes or that needs to run, or half an hour, or maybe a really large compute? Then basically serverless is not that good. Okay, and when you go further ahead and you would say, okay, so maybe divide it to smaller things to run on serverless and then maybe other things to run on Kubernetes, I don't want the whole overhead itself to that. And today you have Knative and things running on top of Kubernetes that you can run serverless things and like overutilize all of these kind of things, but it's today. And again, because of that, I said like, I'd rather have something giving value to my customers and then actually having something like really neat and cool and waiting for the perfect solution. Awesome. Any other questions? Any other questions about Kubernetes? Okay, awesome. Thank you very much for coming, for attending. And enjoy the rest of the conference.